गुड मॉर्निंग स्टुडंट्स, आवाज येते का? Hydrolysis, concept of hydrolysis. This part is yes. Last lecture we discussed this concept of hydrolysis. Salt of strong acids and strong bases. This is completed. So once again, I'm repeat the concept of hydrolysis means what? Hydrolysis means the reaction in which the ions of salts. See, this concept of hydrolysis I explained in last lecture. So in case of hydrolysis, what is happening? The ions of salt. Ions, there are two types of ions. One is positively charged cation and negatively charged anions. So the reaction between these cations and anions with reaction with water means the reaction with H3O plus and the reaction with OH minus. This is called as hydrolysis to produce acidity or basicity. This concept is called as hydrolysis. So in last lecture, this salt of strong acid and strong base, it is completed. This solution is neutral solution. Now we will discuss this part. See, this CuSO4 copper sulfate, this copper sulfate is the salt of strong acid. See, the strong acid is H2SO4 and the weak base is CuOH twice. This is copper hydroxide. So this CuSO4, this salt is prepared by strong acid is H2SO4 and weak base is copper hydroxide. When this CuSO4 salt dissolved in water, it dissociates completely. See, CSO4, it dissociates completely. It forms Cu2 plus cations and SO42 minus anions are formed. So these SO42 minus ions of the salt having no tendency. They do not having tendency to react with water because when this SO42 minus, because it is as it is negatively charged, it reacts with positively charged H2 plus. So the product form H2SO4, it is a strong electrolyte. So as the possible product H2SO4 is a strong electrolyte, so SO42 minus ions, they do not having tendency to react with water, remember. Then what is remaining? This Cu2 plus is remaining. So what is the role of this Cu2 plus? This Cu2 plus, they, as these are positively charged, they reacts with OH minus ions of water. So this Cu2 plus ions, they reacts with OH minus ions of the water and they forms CuOH twice. This is unionized. Remember, this is unionized means it will be partially dissociated, or it will be not ionized. It do not produce ions. It is called as unionized copper hydroxide. So the equilibrium is given here. The hydrolytic equilibrium of CuSO4, it is given Cu2 plus. It reacts with water. They forms CuOH twice, copper hydroxide. It is prepared, and twice H3O plus. Ions, hydronium ions are prepared. So due to the presence of these hydronium ions, remember, due to this presence of excess of these H3O plus ions, we can clearly see in these reactions excess of H3O plus ions are prepared. So the solution of CuSO4, it becomes acidic. Why it is acidic? Because these ions are H3O plus ions are prepared in large amount. In large excess, these ions are prepared. So the solution becomes acidic. It turns blue litmus paper. Red. So this is indication of the solution is acidic, and opposite to this basis, red litmus paper when turns blue, it is called as basic. So this is unionized CuOH twice. It is sparingly soluble. It is not completely soluble. So CuOH twice. This is prepared. This is called as copper hydroxide. On hydrolysis, it makes the solution turbid. So because of this formation of CuOH twice, it is called as copper hydroxide. The solution of CuSO4 becomes turbid. Turbid means like precipitate form, precipitate, not clear solution. It is called as turbidity. Turbidity is appeared due to the formation of this CuOH twice, remember. So in case of H2SO4, H3O plus, if the H3O plus ions are added in the copper sulfate solution, the solution becomes clear, remember. So to remove this turbidity, we have to add more H2SO4. More H2SO4 means we have to add, that is H3O plus ions. So if the more H3O plus ions are added in the copper sulfate solution, this turbidity will be removed and the copper sulfate solution becomes clear. So this is a hydrolysis of salt of strong acids and weak base. Then the next part will be salt of weak acid and strong base. So this is a CH3COONA. Yes, anyone can tell me what is the name of this salt? I already given you access to unmute yourself and tell me. Yes, anyone participants? Sresh 186. Sresh Satralkar. Sresh Satralkar, unmute yourself and tell me the name of this salt. What is the name of this salt? CH3COONA, or anyone who knows the answer can unmute and tell me the answer.
Sir.
Yes, anyone?
Sir, sodium acetate.
Yes, very good. This is the sodium acetate. This is the salt of weak acid. So weak acid in this, it is a weak acid, acetic acid, you know, this is a weak acid. It is a partially dissociated. So this salt is prepared by weak acid. It is acetic acid, and strong base is NaOH. When this salt is dissolved in water, it dissociates completely. So the dissociation is given by it forms the cations and Na plus anions, then acetate anions and Na plus cations are formed, And water, you know, the pure water dissociates slightly and it forms the H3O plus and OH minus ions. So this is a dissociation of water, water dissolved in water. Already we learned this in ionic product of water also. So pure water is partially dissociated and it forms H3O plus and OH minus ions. The solution of CH3COONA. See, in the solution of CH3COONA, it will contain Na plus, it will contain CH3O plus, it will contain CH3CO minus, and it will contain OH minus. So these cations and anions are present in the solution of CH3COONA. We can see here CH3CO minus is there, Na plus is there, H3O plus is there, OH minus are there. So all these cations and anions we togetherly called as ions. These ions are present in the solution of CH3CONA, that is sodium acetate. Now we are coming to this Na plus. Na plus ions of the salt having no tendency to react with OH minus. Yes, anyone can tell me why this Na plus ions having no tendency to react with OH minus? Yes, tell me anyone. No one? Because when...
Sir, because the
yes, tell me.
sir, because the product form is strong electrolyte.
Very good, very good, very good. Because the product NaOH, it is form, it is a strong electrolyte. So it having Na plus ions, salt having no tendency to react with OH minus. In previous example also, we discussed this. SO4 2 minus ions having no tendency to react with water because H2SO4 product is formed, and as it is a strong electrolyte, SO4 2 minus ions, they do not having tendency to react with water. The same Na plus ions of the salt having no tendency to react with OH minus because the product is NaOH and it is a strong electrolyte. Then who is remaining? This acetate anions are remaining. So on the other hand, the reaction of this CH3CO minus, this is acetate ions of the salt with H3O plus ions of the water, they produces unionized acetic acid. See, it is unionized acetic acid, means it will be partially dissociated. So CH3CO minus plus H2O, they gives this is unionized acetic acid is prepared here. So the equilibrium is given. The hydrolytic equilibrium of this sodium acetate, it is given. It forms CH3COOH plus Na plus OH minus. So excess of this OH minus ions are produced. Excess of OH minus ions are produced. Due to this excess of OH minus ions, the solution becomes basic, remember. So this is a salt of weak acid and strong base. The solution is basic. Why it is basic? Because this excess of OH minus ions are produced. Due to this excess of OH minus ions, the solution of this sodium acetate is basic, remember. So if it is asked for the examination, we have to write, it will be asked for 2 marks, remember. No any question will be asked more than 2 marks on this part. The examiner can ask the question like this: why the solution of, or explain, the question will be asked like this: explain sodium acetate solution is basic on the basis of hydrolysis. So the question will be framed as like this: explain why the solution of this sodium acetate is basic. Explain this concept on the basis of hydrolysis. Or they can frame the question another type of question, but The question will be asked for 2 marks, remember, if it is asked. Then the next type of salt is salt of weak acids and weak base. Both are weak. Acid is also weak and base is also weak. Suppose this is a salt, the name of the salt is Ba. This Ba salt, it is prepared with weak acid is Ha. Ha is the weak acid and weak base is BOH. So yes, anyone tell me screen is visible? Anyone?
Yes, sir.
Yes.
Okay. Because there is some issue of internet. So this Ba salt, it is a salt of weak acid Ha and weak base BOH. When this salt is dissolved in water, B plus and A minus ions are prepared. So the hydrolysis reaction involves, so when these B plus and A minus, when they undergoes hydrolysis, they forms weak base BOH and weak acid Ha. So weak base BOH and weak acid Ha, these are the products are formed. Means the solution may be acidic or solution may be basic or the solution may be neutral. This will depends upon the strength of weak base and weak acid. The strength of weak base and weak acid. This will be solution will be depend upon the strength of weak base and weak acid, and so there are 3 possibilities when the solution is acidic, when the solution is basic, or when the solution is neutral. This will depends upon these Ka and Kb values. You know these Ka values. If the value of K is larger, then the solution will be acidic. When the solution of Kb is larger, then the solution will be basic. And when the values are same, Ka and Kb values are same, the solution becomes neutral. So again, there are 3 types depending upon the K and Kb value. So the Ka value is more, the solution will be acidic. Kb value is more, then the solution will be basic. And these values are K and Kb are same, the solution becomes neutral. So we will discuss all these 3 cases one by one. First one is the value of K is, see, this is the salt of weak acid and weak base. All these are the salt. All these salts will be the salts of weak acid and weak base, but depending upon the values of K and Kb, it will decide the solution will be acidic or basic. First, we will discuss. This is NH4F. Anyone can tell me the name? Anyone can tell me the name of this salt, NH4F? This is the salt like NaCl, sodium chloride. This is also salt. It is prepared with one acid and one base.
Ammonium chloride.
Yes, very good. It is the salt of weak acid, HF. Remember, anyone can tell me HF, why HF is a weak acid? HF is a weak acid, why? In the chapter number 7, also we discuss in detail HF, HCl, HBr, HI. HI is a very strong acid, HF is a very weak acid. Anyone can tell me why it is a weak acid? Because it is asked for board exam also. Explain why HF is a weak acid. Anyone can unmute and tell me. Why HF is a weak acid? No one? Yes, I will tell you why HF is a weak acid. Acidity depends upon the release of hydrogen. Remember, if the hydrogen and if hydrogen is easily removed, it will be the strong acid. Remember, and if the hydrogen requires more energy to release, means to break this bond, HF. So to breaking the bond between hydrogen and this fluorine requires more energy, because this bond is very strong bond, and the bond between hydrogen and iodine, HI, means top to bottom, as we go from fluorine, chlorine, bromine, iodine in case of halogens. So the hydrides form will be HF, then HCl, then HBr, then HI. HI is very strong acid because the bond between hydrogen and iodine, this bond is very weak bond. This will be easily broken because the atomic size increases. Iodine having the larger atomic size, fluorine having the very small atomic size. So bond between this hydrogen and fluorine, it will be very strong bond. And as compared to this HF, the bond between hydrogen and iodine is very weak bond. It will be easily broken. So hydrogen will be easily removed. So the HI is very strong acid, remember. So this HI is a HF is very weak acid. The K value is given here. 7.2 into 10 raised to minus 4. This is the K value of HF. And weak base NH4OH, its Kb value is given 1.8 into 10 raised to minus 5. So this Ka values is more than this Kb value. So this salt, it will be hydrolyzed as NH4 plus F minus plus water. They gives this weak base NH4OH, ammonium hydroxide, and weak acid. This is called as hydrofluoric acid. So the acid HF is slightly stronger. The HF acid is slightly stronger than the base ammonium hydroxide. So the two ions reacts with water as these two ions, NH4 plus and F minus. So NH4 when reacts with water, they forms NH4OH plus H3O plus. And then this fluorides, they reacts with water, they form HF and OH minus. So these are the two reactions of the two ions. Which two ions? This NH4 plus and F minus. So separately these two, when they react with water, they form ammonium hydroxide and HF. So here we have to concentrate here H3O plus and OH minus. So in this yes, H3O plus ions are more than OH minus ions. See, in these two reactions, reaction number 3.19 and 3.20, in these reactions, these H3O plus ions are the amount of H3O plus ions are more. Why this is happening? Because this NH4 plus ions, hydrolyze slightly greater than F minus. So this hydrolysis of NH4 plus is slightly greater extent than the hydrolysis of this F minus. So the percentage of H3O plus ions, this percentage of H3O plus ions is more than this percentage of OH minus. So as the percentage of H3O plus ions is more, this solution becomes slightly acidic, remember. The solution becomes slightly acidic. Why it is acidic? Because the percentage of H3O plus ions is more than the percentage of OH minus ions in the hydrolysis. Then again, second example, in this Kb values is more than the K value. See, again we will discuss these are the salts of weak acid and weak base. Yes, anyone can tell me what is the name of this salt? Yes, tell me fast. Anyone? NH4CN. Very easy name.
Ammonium cyanide.
Yes, ammonium cyanide is a salt of weak acid, where weak acid is HCN is a weak acid and weak base is NH4OH is a weak base. The K and Kb values are given in the bracket. So the K value is 4.0 into, values are not important, remember. Values are not expected from the student, only it is expected whether it is a strong acid or strong base. So NH4CN, it is a salt of weak acid and weak base. Weak acid is HCN, weak base is NH4OH. Kb, Ka value and Kb values are given. Here we can see this Kb values, Kb value is more than this K value. See carefully, it is 10 raised to minus 10 and it is 10 raised to minus 5. Don't go for this 4.0 and 1.8. So the Kb value is more. So when this salt NH4CN dissolved in water, it hydrolyzed as NH4 plus Cn minus, then H2, they forms weak base NH4OH, weak acid HCN. So as the Kb value is more, this Kb, as the Kb value is more, so this the base NH4OH, it is stronger than the acid HCN. So the ions, these ions NH4 plus and this Cn minus, when they react with water, they forms NH4OH plus H3O plus, then Cn and O minus. O minus. So sorry. In this, the Cn minus ions hydrolyze to a greater extent than NH4 plus. You can see clearly here. The Cn minus ions hydrolyze to greater extent than the NH4 plus ions. Yes, anyone can tell me why this is happening? Anyone can tell me? The Cn minus ions hydrolyze to a greater extent than NH4 plus. Yes, anyone can tell me why this is happening? No one? See the previous example also. In this previous example, we can see clearly the NH4 ions hydrolyze to a slightly greater extent than F minus. And in this example, we can see clearly, sorry, yes. The base NH4OH here, we can see it is both are weak acid, one is a weak acid and one is a weak base, but the Kb values of this NH4OH is more. So it is NH4OH is stronger than the acid HCN. NH4 plus H2O. These are the NH4OH and H3O plus. These are the ions are prepared, and when this cyanide reacts with water, this SCN and OH minus is prepared. But in this case, the reaction 3.22 produces OH, more OH ions. See, these OH minus ions are more than this H3O plus. So you know, when the amount of OH minus is more, when the amount of OH minus is more, the solution becomes basic. And if the amount of H3O plus is more, the solution is acidic. So if we compare the previous one also, we can get the answer. If the K value is more, the solution will be acidic, and if the Kb value is more, the solution will be basic. Remember, when the Kb value is more, then the solution will be basic. And when in the third example, we can see here, if the Ka and Kb value, we will discuss later. So when the salt of weak acid and weak base, Kb value is more, the solution will be basic. Ka value is more, the solution will be acidic. So this solution of this NH4CN ammonium cyanide solution, it is a basic when undergoes hydrolysis. Then we will discuss the third example. It is also the salt of weak acid and weak base. Only one change is Ka and Kb values are same. So this is a ammonium acetate, ammonium acetate. This is the salt of weak acid is acetic acid. Its Ka value is given, and the weak base is NH4OH, ammonium hydroxide. It's both the Kb values are same. Ka and Kb values are same. So see, the Ka value and Kb values are same here, so the solution becomes neutral here. Means in this example, the amount of OH minus prepared and the amount of H3O plus ions prepared, these are exactly same. Otherwise, other explanation is as it is previous. So this salt CH3COONH4, this is ammonium acetate salt. When it is dissolved in water, it forms the weak acid, acetic acid, and it forms the strong base. When these ions CH3CO minus ions, when they react with water, they form acetic acid plus OH minus, and this NH4 plus, when they react with water, they form ammonium hydroxide. In these two reactions, the amount of OH minus and the amount of H3O plus, these are exactly same. So the solution becomes neutral, remember. So make a practice at your home, write the reactions. If you make a practice, then you can understand why the solution is acidic, why the solution is basic. I will give ideas. When this Ka values is higher, the solution will be acidic, remember. Then when the Kb value is more, the solution will be basic. And when the values of Ka and Kb, these are the same, then the solution becomes neutral. Then I'm coming to the next part, buffer solutions. For the definition purpose, it can be asked what is meant by buffer solution. So buffer is a solution whose pH remains same when the acid is added or when the base is added. The pH of the solution does not changes. So for the examination purpose, a definition is prepared: a solution which resists means whose pH remains same, which resists the drastic changes in pH. So when the small amount of strong acid is added or the strong base is added, the pH of the buffer solution remains same. This is called as buffer solution, remember. When the strong acid is added or strong base is added, the pH doesn't changes. This solution is called as buffer solution. So for the definition purpose, this can be asked for 1 mark. What is meant by buffer solutions? Then there are two types of buffer solutions. One is a acidic buffer solution. It is used to maintain the acidic pH, and the basic buffer solution, it is used to maintain the basic pH, alkaline pH. So first we will discuss the acidic buffer solution. Acidic buffer solution, the definition is also important. What is meant by acidic buffer solution? It is prepared with weak acid, remember. Weak acid and its salt with strong base, remember. This is called as acidic buffer solution. Acidic buffer means weak acid and its salts with strong base. So anyone can tell me what will be the definition of basic buffer? Anyone? What will be the definition of basic buffer? Hitesh, unmute yourself and tell me what will be the definition of basic buffer solution. With the help of this acidic buffer solution, we can write the definition. No one? So the basic buffer solution will be, instead of this weak acid, there will be the weak base, and it salts with strong base. It will be it salts with strong acid. Exactly opposite. So in the next slide, we will discuss the basic buffer solutions. Before the basic buffer solution, understand what is meant by acidic buffer. So acidic buffer solution, always it is a solution containing weak acid and its salt with strong base. This is called as acidic buffer solution. For example, it is given a solution containing weak acid such as acetic acid. It is a weak acid and its salt with strong base, CH3CONA. It is a salt with strong base. It is a acidic buffer solution, remember. So for the board examination, they can ask the definition of acidic buffer solution. So we have to write this definition. And if the example is asked for the board examination, we have to write this example. A solution containing weak acid, acetic acid, and its salt with strong base. It is a sodium acetate. So the pH of acidic buffer, the pH of acidic buffer is given by pH is equal to, we have to remember, this is a very, very important equation. Equation number 3.23 is very important. pH is equal to pKa plus log to the base 10 molar concentration of salt divided by molar concentration of acid, where pKa is equal to minus log 10 to the log to the base 10 Ka. And what is this Ka? You know, this is a dissociation constant of the acid, and Kb will be the dissociation constant of base. So this equation for basic buffer, it will be, instead of this pH, it will be POH. Instead of this pKa, it will be pKb. Remaining, this is same, log 10 salt divided by, instead of this acid, it will be base. So what is the change? See, in acidic buffer and basic buffer, this expression is same. Only instead of this pH, we have to write here POH. Instead of this pKa, we have to write here pKb. Log to the base 10 salt divided by acid, and here will be salt divided by base. So these two equations, equation number 3.23 and equation number 3.25, these are the very specific equations. These equations are called as Henderson-Hasselbalch equation. These are the name of the scientist who derived this equation, Henderson-Hasselbalch equation. As only 1 minute is remaining, in the next on Monday's lecture, we will discuss the basic buffer solution. So today, make a practice of this hydrolysis of salts, salts of strong acid, strong base,